This is experiment number 4, heat transfer coefficient of forced convection apparatus. So in this experiment we are going to determine the heat transfer coefficient of air. So this is voltmeter reading. Here you will get the current reading. So this is T1 to T6. So at the bottom you will be having a blower. So here you can determine the manometer height readings. So initially I am going to switch on the blower on this experiment. So initially you have to set the blower speed by adjusting this knob, so that you can take the H1 and H2 readings from this manometer tube. So this knob is for adjusting the voltage readings. So this is your specified blower and experimental setup of this equipment. So this is blower. So through the blower the air enters into this tube. So through this tube the air enters and it goes outside through this way. So here you will be having a thermocouple which is indicated by T1. At the outlet you will be having one more thermocouple which is indicated by T6. So you have to take the average of T1 and T6 for inlet and exit temperatures. So between T2, T3, T4, T5 are the thermocouples which are fixed at these places. So you have to take the average of that T2, T3, T4 and T5 in order to determine the thermal temperature difference of this setup, that is air. So you can take the readings T1, T2, T3, T4, T5, T6 with this digital values. So now I am going to switch on. So now blower is switched on. You can take the H1 and H2 readings from this manometer tube. So this is your voltage value and this is your current value. So these are the values from T1 to T6. So after switching on you have to wait for 5 to 10 minutes for saturation conditions. So after 5 minutes, so you can take the value of T1. So if you turn this you can get the value of T2, T3, T4, T5, T6. So pipe diameter is 40 mm, orifice diameter is 24 mm, heater is 500 mm. So this is the experimental setup. So voltage readings I am taking 85, so current reading is 1.5, so inlet temperature that is T1, so that value I have noted from here, so this is T1. So and finally in this tabulation you are getting a T6, so this is T6, at the end you are getting this T6. So next to T2, T3, T4 and T5 are the values which we get from this thermocouple values. So this is manometer reading, which is a pressure or a height difference between your H1 and H2 values. So for finding the heat transfer coefficient, so heat input Q can be calculated from this formula, which is HA into LMTD. So that is MCP into change in temperature. So that is the temperature of the tube minus temperature of air. So M is the mass of air, Cp is the specific heat of air. So how will you find the LMTD is average temperature of tube minus outlet air temperature minus average temperature of tube minus inlet temperature of air divided by 1 ln into average temperature of tube minus outlet air temperature divided by average temperature of tube minus inlet air temperature. H is the heat transfer coefficient. So A, that is the area of heat transfer, which can be calculated from the ideal equation. So here the diameter is 40 mm and length of the tube is 500 mm. So with this we can calculate the area of this test tube. So from the above, heat transfer coefficient can be calculated. So for this we are going to determine the manometer readings also. So that is coefficient of discharge, H1, H2, A1 area of the tube, A2 area of the orifice. Those values you can include and find the mass flow rate of the air that is entering into your tube specimen. So after this you can calculate Nusselt number, that is from HD divided by K. So where D is the diameter of the pipe, V is the velocity of air, K is the thermal conductivity of air. So Nusselt number equation can be taken from your data book. So that is 0.03, Reynolds number power 0.8, Prandtl number power 0.4. So this equation you can get from heat and mass transfer data book. So average temperature of heater, which we already know, that is T2, T3, T4, T5 divided by 4. you can get the average temperature of heater. So and the average temperature of air is T1 plus T6 divided by 2. So diameter of the pipe is 40 mm and the diameter of the orifice is 20 mm. So you can calculate the total volume of air by this equation. Then finally H can be calculated, that is a density of water divided by density of air into H1 minus H2, which we can get in terms of meters. So from this we can calculate the value of Q. So that is the velocity of air flow. Next you can find the value of Reynolds number for the different values of readings which we have taken. So from that we can calculate Nusselt number, so that is HD divided by K. So this equation we can take from a data book. So H equal to Nusselt number into K divided by D. So thermal conductivity values, that is you can obtain from your data book. Finally you can get the value of heat transfer coefficient. For 3 readings I have taken the heat transfer coefficients, which is in terms of meter square per second. Thank you.